Welcome to Calculus.
Our stress tolerance level has risen so high that nothing phases us.
On this episode, Stevenson will demonstrate
We've seen what mean value theorem is as a formula, right? Well, how do we use it in practice? So I have two examples for you. Here's the first one. Let f be the function given by f of x equals this cubic polynomial. What are all the values of c that satisfy the conclusion of the mean value theorem of differential calculus on this closed interval? First, what we want to do is make sure we remember what the mean value theorem formula is. So in this case, my interval is 0 to 3, so that's my a and that's my b. And c is going to be the whatever unknown number that I'm looking for. So what I want to do is figure out what's f prime at some c value, and I literally will use c, and then I'm going to set that equal to whatever I get over here. And when it says f of b and f minus a, I'm literally going to take these two numbers and plug them into my equation. So the first thing I want to do is figure out this expression on the right hand side. So this expression on the right hand side, when I plug in 0 and 3 as my interval, I get out 0. Kind of disappointing, really. Now I'm going to find my derivative and substitute c in. So I have my derivative evaluated some unknown c, and then I have my average rate of change on that interval. So now I'm going to set these equal to each other and solve. I have my c values. Now remember, what was the requirement of mean value theorem? The function had to be continuous on a closed interval. So we know this is continuous on a closed interval because it's a polynomial function and the interval is closed. The second requirement is it had to be differentiable on the open interval. Well, this function is polynomial. It's continuous everywhere, and it's a cubic, so it's differentiable everywhere also. And on the open interval 0 to 3, that would still hold true. Now here's the thing. According to the mean value theorem, that if those conditions are met, which it is true, it does meet it, there's a c value that exists in the open interval, and that will be a number that satisfies mean value theorem. So let's go back to our problem. We have 0 and 2. We look at our answer choices and we're, wait, we have two answers. That's a sign to go, wait, 0 is one of my endpoints, so we exclude this one, because that's not what mean value theorem says. That means 2 only is our answer.